All right, we classified them by their angles. Now we're going to classify the triangles by their, what? Their sides. Oops. Good. All right, so let's talk about them. So we're not going to talk about whether the angles are equal to each other or what kind of angles we have and all that kind of stuff. What we're going to do is we're going to classify them by their sides. All right, so I tell you what, we ended with this. Let's start with this time. Now we're talking about the sides. I'm not talking about the angles this time. You got it? I'm only talking about the lengths of the sides. What do you think? Now you don't know, but just a guess. What do you think might be true possibly about all three of these sides?
They might be equal.
Yes, and they are. I made it, and I copied and pasted all the sides, and they are exactly equal to each other, okay? So they are equal to each other. So now this will give you another chance. If all the sides are equal to each other, what kind of a triangle do you think we call this?
Angular.
Not angular. Come on.
Lateral.
Right, I said I'll give you another chance at it.
I said it.
That was a different.
Lateral. Lateral means sides. Look, if I go side to side, that means I'm moving laterally. Lateral, okay? For those who play sports, a lot of times in drills and stuff like that, they'll do like a lateral drill, which means you go back, you go back and forth. Lateral means side. You got it? Lateral means side. Equa, of course, means equal, right? Equilateral. Look at the spelling, E-Q-U-I. My goodness. On the test, I said, is it perpendicular, parallel, or neither? And guess what? On the test, it was spelled parallel. It was right there on the test. But what do I get? I get all kinds of crazy spellings. I got P-A-R-R-A-L-L-E-L-L, and I got all kinds of stuff. And for goodness sakes, it's not understandable because it's right on the test. It's right on the test how to spell the word. I didn't ask you out of the blue. It's right there in front of you, okay? I didn't mark off for that, don't worry, but that bothers me just a little bit. I didn't take off for that, but I did point it out to a few people, though. All right. So anyway, here we go. Let's spell things correctly. Equa, E-Q-I, equilateral, L-A-T-E-R-E-A-L. Okay, it's E-Q-U-I. It's not E-Q-U-A. Right? It's an I. Equilateral. Got it? Which means what? All what? All three sides are equal. Okay, enough of that. We killed that already. So let's do another one. I'm going to do that in a sec.
What's a lateral meniscus?
I don't know. Ask anatomy teacher. I don't know. Let's see. What do I want to do now? Oh, I don't want that one. I want this one. Oh, what did I just do? All right, here we go. Look at this one right here. Now, what do I know about the sides? Not just guessing, but just from the information that I've given you. I've only given you this triangle. You know two sides are equal?
No.
How do you know that? Brett, I don't need that. Talking about the sides. Talking about the sides. Listen, I'm talking about the sides. Okay, you can't say it's a right angle by the sides. Okay? Are any of the sides equal to each other? No. Okay, watch. No sides are equal, and we give that a name. This is kind of a different name. We call it a scalene triangle. S-C-A-L-E-N-E. Okay, it's not hard to spell. Scalene. Just like it sounds, doesn't it? All right? Scalene triangle. It's a scalene triangle if none of the sides are equal. No sides are equal to each other. Okay, it's called a scalene triangle. We won't do a whole lot of stuff with scalene triangles, but it's nice to know what the name is. All right, let's do another one. Let me get this thing again. Okay, but I'm gonna do something with it here. Watch. Actually, let's do that. Okay. That's right. So watch. Now you don't know right now until I do this, right? If I do that, what can you say? How many sides? Okay, we can say two sides are equal to each other, correct? Now listen to me carefully. The definition, this is an isosceles triangle. Isos. Let's spell this right. Watch how I start it. Isos. I-S-O-S. Isos. Pretty easy, right? The second part is the part that people get messed up on. Celes. C-E-L-E-S. You know Celine Dion? You ever heard of her? Some singer, right? I can't stand her, but she's Canadian, right? So that's not why I don't like her, but she's just Canadian. I don't know. So Isosceles, C-E-L. She spells her name C-E-L-I-N-E. Did you know that? Celine Dion. So C-E-L-E-S. So if you don't know how she spelled her name, I guess that wouldn't help you much on this. But it's I-S-O-S-C-E-L-E-S. Isosceles. Let's pay attention up here. Up here. So it's an isosceles triangle. What's an isosceles triangle? Two sides are equal. Now, I have to tell you this. The true definition of isosceles triangle says at least two of the sides are equal, which leaves the door open to what? It could be equilateral, right? So an equilateral, do you have at least two sides equal on that? Yeah, you do. All right, so I could call this triangle right here isosceles as well. But just to make it easier, let's just say if exactly two sides are equal, let's just call that isosceles. Is that all right? So let's not call this isosceles. Let's call this equilateral. But we'll only use isosceles when only two of the sides are equal. I might be breaking some rules here. Some geometry teachers may be upset if they heard me say that, but that's okay. They won't be watching this
You're on
anyway.
YouTube.
All right, I am on YouTube, but nobody watches my videos anyway. Yeah, they won't though. Khan gets thousands and thousands of hits, and I get 2 or 3 or 4 hits. So I don't think I'm worried about geometry teachers looking at what I'm doing. All right, so anyway, here we go. So isosceles triangle means two of the sides are equal. Two of the sides. Everybody got that? All right, that's pretty easy. Let's do another one. Where is the other one? That's it. I think that's it, isn't it? Scalene isosceles equilateral.
I think you're a better teacher.
Yeah, I think that's it. Now, Khan's a great teacher. I'm not a very good teacher. Let's do an example, okay? Let's do an example, and I'll show you how we can actually do a little bit of math with this stuff. All right, here's a quick little example. This is on page 237 if you really want to look in the book for this, but I'll take care of all that. And it's example 5. All right? So what we're going to do is they say to solve for x. So we're going to do a little bit of math here, but we're going to use what we just learned, okay, to actually, we could have done this before we learned the stuff today. This is a pretty simple problem, I think. So we want to solve for x. So what's the relationship here? Do we know a relationship between any of the things? Very good. These two sides are equal, aren't they? AC equals BC. So that means that this is the length of this segment. This right here, 5x minus 0.5, is the length of this segment. What's true about the two? They're equal to each other. So it's this one right here, BC. Right? It's right next to this. So it's not that one. It's not that one. It's this one. Right? So 4x plus 1 plus what? Or not plus. What am I doing? It equals, doesn't it? It equals that side right there. 5x minus, I'm going to put just 0.5. Is that all right? Instead of the 0. So you set them equal to each other. Now what do you do after you set them equal to each other? You solve for x. Solve for x, right? Okay. Let's get the x. I like to get the x's on the same side first. All right, so you could do this a couple different ways. This is not the only exact way to do this problem. I like to take the smaller x and put it on the side with the bigger one just so it comes out positive. I just think that's a little easier. If you wanted to, you could have subtracted a 5x from both sides, couldn't you? But then you'd get a negative 1x. Do you really want that? No. So I like to put it over here. So watch what happens. This cancels out, doesn't it? I got my x's on the right-hand side. What am I going to move over to the left? 0.5. It's a minus 0.5. How do we get rid of it? We add it, right. So I add a 0.5. And then what do I do to the other side? Add a 0.5. Everybody see that? That adds up to 0. 5x minus 4x is 1x. Equals what? 1.5, exactly. So that's what x is equal to. And there it is. Well, what does it say to do? So we're done, aren't we? Okay, what if? All right, here's a big what if. What if they said this? Find AC, BC, and AB. Now, if you don't have a line segment over it, what does that mean? We learned that in the first chapter. It means the what of AC? What kind of the distance? The length of, right. Yep, it's the length of AC. All right, so if it doesn't have a symbol over top of it, it just means find the length of it. So find AC. Well, what do? Here's AC. Plug in at 1.5. Exactly right. So plug it in. 4 times 1.5, can you do that in your head? 6 plus 1 is, so what's AC? It's just 7. Now, without doing any math at all, what's BC equal to? 7 as well, right? Because these two sides are equal to each other. But just for fun, let's put it back in anyway, just to make sure, okay? Anybody know what 5 times 1.5 is? It's 7.5. What's 7.5 minus 0.5? It's 7. So it does work, doesn't it? So they are equal to each other. All right, what about this one right here? 9 times 1.5. I think that, let's see, that's 9. What's half of 9? 4.5, right? So what is that? It's 13.5. Minus 1 is what? 12.5. Did I do that right?
Yes, you did.
Okay, 12.5. Now, if you wanted to do that, you could. Okay, they don't ask you to do that. I just said, I mean, they could on a quiz or a test, couldn't they? That's definitely something that they could do on a quiz or a test. So there you go. That's not too hard, is it? So make sure you're able to classify. Let's do this. Classify this by its angles. What kind of triangle is this by its angles? It's obtuse, yeah, because that looks obtuse, doesn't it? Yeah, sometimes if I put it on a quiz or a test, it'll be an obvious obtuse or not, okay? So you're right. You just have to go by what it looks like, and I hate to do that in geometry, but that looks obtuse. It definitely looks obtuse. All right, so it's an obtuse, and so by its angles, it's obtuse. Classify it by its sides. What is it according to its sides? Isosceles. So you would write, actually, you would write first what? Obtuse, and then you would write isosceles. Spelling both of them correctly, right? Does it make sense? So I could ask you for both. I think on the worksheet I'm going to give you today, I don't think they ask for both. They just ask for one or the other. All right? But read the instructions. Make sure you know how to do it. All right, I'm going to give you a worksheet, and that'll be due tomorrow.